Earth didn't just create life, it almost wiped it out 5 times. Since life first appeared on this planet, Earth has followed a brutal cycle. Life emerges, life thrives, and then the planet itself turns hostile. Not because of aliens, not because of mistakes, but because Earth is dynamic, unstable, and constantly changing. These were the most dangerous moments in Earth's history, and if you were alive during them, survival wouldn't depend on intelligence or strength. It would depend on luck. This is what it would be like to live and die during the deadliest mass extinctions Earth has ever seen. We begin nearly 500 million years ago. We arrive in the Ordovician 485 million years ago. The air is strange, the coastlines raw, and the continents mostly barren rock beside restless seas. On land, only thin films of algae and primitive moss cling to damp stone near the water's edge, an alien fringe on a largely empty world. Beneath the waves, life blooms. Warm, shallow seas cradle intricate reefs, and evolution surges forward in a riot of new forms. This is the Great Ordovician Biodiversification Event. Trilobites carpet the seafloor. Straight-shelled cephalopods prowl like living spears. Jawless, armored fish weave between corals, testing futures none can yet imagine. Then the planet shifts. Gondwana slides over the South Pole, and bright ice reflects sunlight back to space, ratcheting the world colder, step by step. Snow persists through summers. Ice sheets thicken mile upon mile. Water locks on land, and global sea level falls, draining the warm, life-filled continental shelves. Cold, dense waters overturn the oceans and strip oxygen from the depths. Sinking detritus feeds bacteria that devour what little remains. Vast, suffocating dead zones spread through once vibrant seas. In a geological instant, more than 85% of marine species vanish in the first wave. Food webs snap, reefs collapse, silence spreads. If you were there, you'd stand on a new shoreline, miles from the old sea. A bitter wind scours freezing mudflats. The stench of stranded life thick in the air. There is nothing to eat. Eventually the ice retreats. Life endures. After the Ordovician recovery, the continents turn green. The first true forests rise, knitting a living roof over a once barren land. Roots bind slopes, building riverscapes while oxygen climbs. The world feels stable, orderly, full of promise. Beneath the surface, it is the age of fish. Reef cities bustle with life, patrolled by apex hunters like Dunkleosteus. In the shallows, lobe-finned pioneers test a new frontier. Fins pushing mud, lungs tasting air. But the trees change more than scenery. Deep roots fracture bedrock, unlocking nutrients long trapped in stone. Rain carries those nutrients into the sea, a flood of fertilizer. The oceans bloom. Up close, the water turns soupy. Blooms surge, die, and sink. Bacteria feast and strip oxygen from the depths. Reefs suffocate. The food web unravels. Most lineages fade as the seas quiet and simplify. No single blow, just a long, breathless decline into stillness. Then comes the worst extinction Earth has ever known, the Great Dying. A quiet world on the brink. Continents fused as Pangea, warm seas bright with life. Then the crust rips open. In Siberia, a mantle plume punches through, birthing a province of fire. For nearly 1 million years, the Siberian traps bleed. The eruptions exhale staggering volumes of carbon dioxide. A chain reaction grips the planet. Runaway greenhouse, acidified oceans. The toll is staggering. About 96% of marine species gone. Earth nearly resets, a ghost world stitched with ash. Recovery will take millions of years. In the quiet after the Great Dying, Earth begins to recalibrate. Rivers cut fresh paths through cooling lava, and from deep fissures, flood basalts ooze across the land, remaking continents. The climate swings from seasons of dust to seasons of deluge. With each swing, winners and losers trade places. New lineages seize empty roles, testing new ways to endure the instability. Survival favors the modest. Small bodies, generalist diets, and the ability to burrow become lifelines. Night offers another refuge, where senses sharpen and danger passes by. Dinosaurs rise from small, swift beginnings. Alongside them, early mammals persist as shadows, keen-nosed and hidden in roots and leaf litter. If you hope to endure here, you'd adopt their rules. Stay small, stay flexible, and let the landscape hide you. Because the Triassic never truly settles. The lesson is simple. Survive the swings. The next one is already forming. Late in the Cretaceous, Earth is abundant. Forests breathe, rivers meander, and warm, shallow seas teem with life. Dinosaurs dominate the land, horns, crests, and armored hides moving through green cathedrals of trees. Offshore, reefs and ammonites flourish. The oceans are warm, stratified, and full. It feels unstoppable. Then, far beyond the clouds, a rock the size of a mountain crosses the void. 66 million years ago, it strikes the shallow sea near Chicxulub. In an instant, rock and water vaporize. A fireball blooms, brighter than 1,000 suns. Shock waves circle the globe. Forests fall as if scythed. The sea withdraws, then returns as walls of water. Megatsunamis race across coastlines. Ejecta rains back down as molten glass. The world catches fire. Ash and dust rise into the stratosphere, blotting out the sun. Day becomes twilight. Photosynthesis stalls. Temperatures plunge. Frost rims leaves beneath a snow of drifting embers. The forests go silent. Food webs collapse. On land, herbivores starve. Predators follow. In the seas, plankton fail, and the chain unravels from the bottom up. Yet some endure. Birds, dinosaurs with feathers, find refuge. Small mammals shelter in burrows, living on seeds, insects, and carrion. Freshwater pockets persist. Detritus pathways, fungi and microbes, recycle a broken world into calories for the patient and the small. If you were there, your checklist would be simple. Shelter underground or in tight crevices. Hoard dry fuel and warmth. Eat what you can scavenge. Boil water. Avoid open skies when embers fall. Wait. Endure the cold and the dark. Let the ash settle. And one dim morning, a weak sunrise leaks through the dust. Not warmth, not safety, just the first hint of recovery. And eventually, humans appear. We arrive not at the end of danger, but in a quiet between storms, cities rising, stories shared, light stitched across the dark. In this calm, we built towers and networks, mapped the heavens, and forgot, briefly, that Earth has never been still. Below our feet, plates grind and melt, mountains rise and crumble. Fire writes new crust, ash redraws horizons. From the deep past to now, volcanism breathes heat and gases into the air we share. Above us, orbits cross. Asteroids still wander. Impact is not a legend. It is a schedule with a long fuse. Climates tilt and sway to the rhythms of ocean and orbit. Past extinctions teach 3 hard lessons. Speed matters. When change outpaces adaptation, systems snap. Scale matters. Global shocks overwhelm even robust chains. And cascades matter. One failure pulls 10 more down. Through the modern lens, the risks are familiar. Rapid warming, acidifying seas, intensifying extremes. We are changing the atmosphere faster than many past natural swings. Ecosystems are intricate: reefs, forests, wetlands, each a web of dependencies. In a connected world, a shock in one place ripples through supply, food, water, and health everywhere. Yet life's resilience also leaves a map. Diversify to avoid single points of failure. Protect refugia where recovery can begin. Keep options open so adaptation can find a path. Stewardship is practical. Restore habitats, cut emissions, rebuild soils, reconnect rivers, shield coasts, and listen to the slow metrics: chemistry, temperature, oxygen, that decide futures. We inherited a calm moment. Keeping it requires vigilance, humility, and work measured in generations, not headlines. Life on Earth isn't guaranteed. It is borrowed, briefly, on a changing world. Treat it like something precious.